Good day, grade 11s and grade 12s. Welcome to this session on functions. Very interesting part of functions that we'll be dealing with today. We'll be looking at translations, which is what I normally call shifting of the graphs. We'll also be looking at what we call transformation, which is what I call reflections of graphs. Okay, so when we talk about shifting of graphs, we are saying a graph or a function may shift to the left or to the right, which is what I call a horizontal shift. And then a function may also move up or down, which is a vertical shift. Then, when we transform a function or a graph, we are saying this is when your function is reflected maybe along the x-axis or along the y-axis or about its asymptote. Okay, so let's look at example number 1. We are given a function f of x, which is a parabola, a smiling parabola with its turning point as 0, 0 at the origin. So f of x is equals to x squared, which is the parent function of a parabola. So when you look at the second diagram here, it is still the same parabola like the first one, just that now this parabola is shifted 2 units to the right. Okay, so how would you actually write it down so that the marker can know how you have shifted the graph of f to obtain the graph of h? You would say the graph of f is shifted 2 units, okay, 2 units to the right to obtain h. Okay, so algebraically h of x will be equals to f at x minus 2, where x minus 2 is the 2 units to the right. Okay, because if I were to equate x minus 2 equals to 0, then solve for x. X will be equals to positive 2. Positive means to the right, 2 means 2 units. Okay, so h of x will be equals to, now on f where there was x, we've put x minus 2, and therefore h of x will be equals to x minus 2 all squared. Okay, then let's look at the third diagram here. Same function as f, a parabola, but from f we see that this one has been shifted to the left. How many units? 2 units. Okay, because a minus 2 means, minus means to the left, 2 means 2 units. Okay, so it is the same function, but now we give it a new name, which will be g. G is a function that was obtained by shifting f 2 units to the left. Okay, and then algebraically, if you are asked to write down g, you'd say g of x is equals to f at x plus 2. So remember, the x plus 2 is the shifting that has occurred. X plus 2, if you equate it to 0, then we would get x being equals to a minus 2. A minus means shifted to the left by 2 units. Okay, so that means our function g will be equals to x plus 2 all squared. Meaning, on f where there was x, now we have put x plus 2 all squared because that was the shifting that has taken place. Okay, and then on the next diagram, example number 2, we are having an original function f in black. Then we have 2 other functions, which is h as well as g. Okay, so when you look at h, h is a function f which has been translated 5 units upwards. Okay, that is h. So h was obtained by shifting the graph of f by 5 units upwards. Then the graph of g was also obtained by moving the graph of f 5 units downwards. Okay, so that is a vertical shifting. Okay, we have shifted the function f vertically. Okay, so as I've said, with translations, we can shift the graph to the left, to the right, up or down. Okay, but that is all about the shifting, which we call translation. All right, so quickly, f of x is equals to x squared. Okay, so if then my h of x was obtained from f by shifting f 5 units upwards, then it means we're going to add 5 units to the function f. Okay, so it means h of x will be equals to x squared plus 5. All right, then the plus 5 means 5 units upwards. Similarly, g of x will be equals to f of x. Remember, f of x is x squared. Then it will be minus 5, meaning 5 units downwards. Okay, so the graph of f is shifted 5 units down to obtain g and 5 units upwards to obtain h. Okay, very, very important. Now, few notes. As you have seen in the graph that we're dealing with, graphs can be translated, meaning shifted, left or right, up or down. That is what we call horizontal shifting. Okay, then when we move it up or down, we call that vertical shifting. To the left and right, it's a horizontal shifting. Up or down, it's a vertical shifting. Okay, let's remind ourselves from the previous sessions that we have covered. We said when we have the form of an equation of a parabola, in this case, y equals to a multiplied by x minus p all squared plus q, we said this is what we call the turning point form, okay, of a parabola, where p and q give us the coordinates of the turning point. So why are we telling you this? Because p is responsible for the horizontal shifting. Okay, remember, p is the x value of the turning point. So since you're talking about the x values, it means you're talking about horizontal movement. Okay, so p is responsible for the horizontal shift, and q is responsible for the vertical shifting. Okay, because remember, q was representing the y value of the turning point. Okay, very, very important. So whenever a parabolic function is shifted, okay, the only values that will be affected are your turning points. Okay, but also the y-intercept, the y-cut will be affected. But what we are saying is it's easier to work with a turning point form than the other forms that we have for a parabolic function. Okay. Also, it should be clear now that graphs will have this happening to them. The graph of f at x minus p, very, very important, will shift the graph of f p units to the right. Okay, meaning when I equate this part to 0 and solve for x, I will get x equals to positive p. So that will be a horizontal shifting, and in this case it will be to the right by p units. Okay, and then also the graph of f at x plus p will shift the graph of f by minus p units, or by p units to the left, because when I equate this part to 0, it will be x equals to minus p. Okay, so that will be the graph of f being shifted p units to the left to obtain a new function. Okay, then also very, very important, the graph of f at x plus q. Remember, now we are dealing with a vertical shifting, so plus q means we are moving q units upwards because it's a positive q. Okay, then also f at x minus q, minus means downwards, so we are moving q units downwards. Okay, in this case it means we are talking about your vertical shifting. Well done. Now let's look at activity number 1 and see if we are able to apply the theory. Given the function f of x equals to x minus 3 all squared plus 4, remember from the other sessions I said, when you equate this part to 0 and solve for x, then you are getting the x value of the turning point, but automatically we also have the y value of the turning point, so it means 3 and 4 will be the coordinates of the turning point of f in this case, and I think I've answered A. Determine the turning point of f. Okay, it will be 3 is to 4. Now they say determine the turning point of G. Okay, so the first thing that I would do is to find G and then check what the coordinates of the turning point will be. Okay, so they're telling me that G is equals to f at x minus 1, meaning on f where there was x, now I'm going to put x minus 1. Okay, so let us first find g. So as I've said, turning point of f was 3 to 4. Now we are looking for the turning point of g. But first I want to find g. So we're told that g is equal to f at x minus 1. Then where there is x on f, remember we said we substitute by x minus 1. So there's my x minus 1. Then it will be the minus 3 from the formula of f. Then plus 4. So x minus 1 minus 3 is minus 4. Then this will be squared plus 4. Okay. Then the turning point will then be 4:4. Okay. Because this is the turning point form. And in this case, it means I know what I must do to find the turning point. Next up, we want to look at transformation. Remember here we are dealing with your reflections of graphs. Okay. I have given you 3 functions, which is f, g, and h. When you look at f and g, they are mirror images of each other, okay, along the y-axis. Meaning these 2 functions, they were reflected along the y-axis to duplicate, to look the same, okay. So if f is the original function and its reflection is along the y-axis, we obtain g, okay. But remember, for both of the functions, y values are the same. What is different are the x values, okay. So that means reflection along the y-axis changes the x values, okay. Hence, the turning point of f was minus 2:4, but now, remember, reflection along the y-axis changes x, y remains the same. That's why now we've got 2:4. 4 didn't change, but minus 2 became a 2. Then also, when you look at h is the reflection of f along the x-axis. That means they still have the same x values, but with different y values. The y values of f are positive, whereas the y values of h are negative. Okay, so that means the reflection along the x-axis changes the y values. Okay, hence the x values will remain the same. We still have the minus 2, but now we've got a 4 and a minus 4 because of the reflection. Okay, very, very important. So these are your reflections and you need to master them. Okay, so from the graphs we have noticed that g is a reflection of f. You agree with me? Remember, g on the first quadrant, f on the second quadrant, and this reflection is happening about the y-axis. So if reflection is about the y-axis, what changes? Your x values will change. Okay, so how do we write it algebraically? That means when we write it algebraically, it will be g equals to f at minus x. Remember, it was x, but because there is reflection along the y-axis, x changes. Okay, hence we substitute a negative x. That means if these were the coordinates of f, which is minus 2:4, then reflection along the y-axis will keep the same y values, but x values will change and it will be 2. Okay. Also, very, very important, h is a reflection of f. You remember about the x-axis. So what will change? Y values will change. Okay. So algebraically, when you write it, it means h will be equal to a negative f of x. Remember, f of x and y, they mean one and the same thing. The reason why we multiply by a negative the y values is because of the change whenever there is reflection along the x-axis. Okay, so if the coordinates of f were minus 2:4, then the coordinates of h will then be minus 2, minus 4. Okay, so what remains the same? The x values, but y changed from being 4 to being a minus 4. Okay, very, very important. And then now, in summary, what we're saying is the graph of f at minus x is a reflection of the graph of f about the y-axis. Hence, we see the change in x. Okay, then the graph of negative f of x is a reflection about what? About the x-axis. Okay, That is very, very important. Now, having said that, we want to look at activity number 2, which is on reflections, transformations, okay? Given f of x equals to x plus 2 all squared plus 3, determine g, okay? So we are looking for a new function, which is a reflection of f about the x-axis. So what's going to happen? If the reflection is along the x-axis, y values will change, meaning we must multiply f of x by a negative. All this will be multiplied by a negative because it is f. So how do we write it down algebraically? We're going to say g equals to negative f of x. Therefore, g of x equals to, remember f of x was your x plus 2 all squared plus 3, then multiplied by a negative. Then we distribute the negative, then we are left with a negative x plus 2 all squared. Then positive 3 times the negative is a negative 3. Please take note, this sign here cannot be affected, okay? You cannot multiply with the negative because there is a square there, okay? Very, very important. And then now, let us go to B. B, they are asking us to find H, which is the reflection of F along the y-axis. So if we are reflecting along the y-axis, what's going to change? Our x values, okay? So that means H will be equals to, now on F where there was x, now I'm going to put a negative x. You agree with me? So this will be minus x plus 2 all squared plus 3. And then if I take out the negative as a common factor, it will be negative times x minus 2. So remember, after taking out the negative, just confirm whether you are getting the same thing as previously. Okay, very, very important. So now my final function h will be, remember the negative will be squared, and then I'll be left with x minus 2 all squared plus the 3. Okay, very, very important. Now let us look at an exam question. The sketch below is the graph of f of x equals to 2b to the power x plus 1 plus q. Remember, q is the horizontal asymptote. So in this case, I notice that this is the horizontal asymptote and it's equals to 2. Okay, so the graph of f passes through the points a and b. But look at b, y value, we don't know it. Okay, and both b and a are points that lie on the function. So you can always substitute them in the equation for f if we are looking for an unknown. Okay, so the line y equals to 2, which is given there, is an asymptote of f. Remember, y equals to 2, it means automatically we know what is our q, which is equals to 2. Okay, so they want us to show that the equation of f is f of x equals to 2 times 3 to the power of x plus 1 plus 2. Already, from what I'm trying to show, I have q already, which is 2. Okay, so the only thing that I will do is to substitute a point that lies on the function, then find b from this equation here. Okay, so f of x equals to 2 times b to the power x plus 1 plus q, but remember q is 2. So that means now I'll have to substitute point A, and after substituting point A, remember 1 is x, 20 is y. That means I found b as a 3. Okay, not a negative 3, but a 3. Okay, b is positive. So after finding that b is a 3, I wrote the full equation. F of x equals to 2 times, where there is b, I put 3 to the power x plus 1 plus 2, which was q. Okay, very important. Now let us go to 7.2. Calculate the y coordinate of the point B. Remember, for point B, I know what is the x coordinate, but I don't know what is y, and I think that is what the question is asking us to find. So I'm just going to substitute the minus 1 and the y, which are coordinates of B, in the original equation in order for me to find y. Okay, so with an attempt, substitute b into the equation of f. I found that my y is equals to 4. Okay, therefore the coordinate of b is minus 1 is to 4. Now let us go to the next question. 7.3, determine the average gradient. Average gradient is the normal gradient that we know. Determine the average gradient of the curve between points A and B. So we're going to use the coordinates of A and B to find that gradient, okay? So the gradient formula is m equals to y2 minus y1 over x2 minus x1. I've labeled my x1, y1 and x2, y2 from the coordinates of A and B. Then my gradient is 8. Okay? Very, very important and easy. Now 7.4, a new function h is obtained when f is reflected about its asymptote. Okay? So before a function can reflect about its asymptote, it will first reflect about its x-axis or about the y-axis. Okay, so in this case, because you are dealing with a horizontal asymptote, the function f will first reflect about the x-axis, and then we will then make sure that we maintain the same horizontal asymptote, which is y equals to 2. That means, remember, when we are reflecting a function f, also its asymptote will be reflected, and it will be y equals to a minus 2. But because we want to keep the same horizontal asymptote, we will move from minus 2 to 2. Okay, so how many units will that be? That will be 4 units upwards, meaning we will first reflect the function f about the x-axis, then say plus 4, so that we still have the same horizontal asymptote. Okay, that's very, very important. We are working with the horizontal asymptote, which is y equals to 2. Okay, remember, even if the function is reflected, for the fact that is not, we are not told that is reflected along the x-axis only, then it means we must keep the same horizontal asymptote. Very important. Okay, so we are going to reflect it about the x-axis, then shift it to have the same horizontal asymptote by adding 4 units. So let's do that. 7.4. 7.4, we start by reflecting about the x-axis. So h will be equals to negative f of x, because reflection along the x-axis changes the y. Therefore, it will be the negative multiplying all the function of f, which is 2 times 3 to the power x plus 1 plus 2. When I distribute the negative, then I got this function here. Okay, but remember, this is not the final function. This is not the final answer. Okay, you have only reflected about the x-axis. Now you need to reflect about its asymptote. So what does that mean? It means you need to keep the same asymptote. So since I've got a minus 2 here, how do I get to plus 2? That is by adding a 4. Okay, so immediately I add 4, minus 2 plus 4, I get a positive 2. So the equation of h will be minus 2 times 3 to the power x plus 1 plus 2. Okay, very easy. Then, lastly, the question 7.5 requires us to write down the range of h. What is the range? The range are all possible y values of a function that are defined for that function. All possible y values defined for a function, they form what we call a range. Okay, so in this case, I want to show you the reflection of f about the asymptote, which is h, would look something like that. You agree with me? So that means this function is starting somewhere from a smaller negative value and up to the asymptote. Remember, it will never touch nor cross the asymptote. Okay, so that will be negative infinity up to 2, but not including 2. So the answer to 7.5 will be, the graph starts from negative infinity and ends at 2, but 2 is not included because at 2 the function is undefined. If you don't want to write it in this form, then you can say we are considering all y values that are defined for the function which are smaller than 2, but not including 2. Okay, very important. Now let us go to the last question, where we have a straight line function, a hyperbola, and a parabola. Okay. In the sketch below, the graphs of G, F are given. Okay. So when you look at the graph of G, we already know what the horizontal asymptote will be, and that will be a plus 4. Okay. The asymptotes of G intersected B. So the vertical and the horizontal asymptote of the hyperbola, they intersect at B. And B is the turning point of F. That means once I know the vertical and the horizontal asymptotes of G, then I know the turning point of F. Or if I know the turning point of F, then I know the horizontal and the vertical asymptotes of the hyperbola. Okay. The graphs of F and G intersect at C. So C is the y-intercept of G and F. The axis of symmetry G, which is this, which is that line, that has a negative gradient, is the line H. Okay, that intersects the graph of F at A. Okay, so that line is cutting the graph of F at A, which is 2:3, and also at B. Okay, so it means we can find the gradient of this line, and remember, the gradient of an axis of symmetry will always be a -1 if it is the axis of symmetry with a negative gradient, or will be m equals to a +1 if it's a straight line or an axis of symmetry with a positive gradient. Okay, very, very important. Now, remember, with a hyperbola, I said to you, a hyperbola will always have a two-piece. Okay, it will always be a two-piece function. And then, if the value of A, in this case, we are given a K, if the value of K is positive in this case, then the two-piece functions will be in the first and the third quadrant of the asymptotes. Okay, but if the value of K is negative, then the two pieces will be in the second and the fourth quadrant of the asymptotes. All right. Now, what we know already is the horizontal asymptote, which is from the equation there. Okay, and I wrote it here as y equals to 4, which also is the y coordinate of B. Okay, very, very important. So it means we're only left with the x coordinate of B, which is the vertical asymptote of the hyperbola G, and it's also the equation of the axis of symmetry of F. Okay. Now determine 4.1 the equation of H. What is H? H is the axis of symmetry of the hyperbola with a negative gradient. So the equation, remember, it will be y equals to mx plus c. It's a straight line, but since it's an axis of symmetry, its gradient will be a -1. All right, because it's the axis of symmetry line that has a negative gradient. If it was the axis of symmetry line with a positive gradient, then it will be just a 1. Okay, so y equals to -x plus c. Then we need to substitute a point that lies on the function h. So that will be point A, and therefore I found that my c was equals to 5, and therefore h is equals to -x plus 5. Okay, the equation of the axis of symmetry. Now, next up, 4.2, show that the coordinates of B are 1 and 4. Remember, I already know, as I said, that the horizontal asymptote is y equals to 4, which is also the y coordinate of B. So I can actually substitute it into the equation of the straight line, because B also lies on the straight line. Done. So that means YB is equals to 4, which is the y coordinate of B. And when I substitute it into the equation of the axis of symmetry, then my x became a 1. Therefore, B being 1 is to 4. Okay. Now let's go to 4.3. Show that the equation of f is given by this here. F of x equals to -x squared plus 2x plus 3. So they want you to show that the equation of f is gonna look like that. Okay. So one thing that we need to take note of is we know what the coordinates of B are, which is the turning point of the parabola, and we know another point that lies on the parabola, which is A. Okay, so we can use the turning point form, and find the equation of f. So, doing that, f of x equals to, f of x equals to a times x minus p all squared plus q. We said the turning point are the coordinates of b, which is 1:4. So when I substitute whether it's p and q, there we go. And then I substitute another point that lies on the function. So please do check other sessions of videos where I was dealing with each function at the time. Okay. So when I substitute point A, I found that my A is a -1. Does this correspond with the graph? Yes, it's a set parabola. So those are properties of a parabola. Remember, please check from the other videos. So since I got A being a -1, therefore I substituted where there was A, and there we go, it's a minus. Remember, you can write -1, it's fine, but we usually just say minus, okay? So then I start by simplifying the square binomial. X minus 1 all squared became x squared minus 2x plus 1. Then distribute the negative. I got minus x squared plus 2x minus 1 plus 4. And then when I add the like terms, the equation of f was minus x squared plus 2x plus 3. And we are done. Okay. Now let's go to the second last question. Determine the equation of g. Okay, so what is g in this case? G is our hyperbola. You agree with me? So remember, we already know the horizontal asymptote there. So it means we need to know what is the vertical asymptote. And by virtue of looking, we said if we know the coordinates of b, we will know the vertical asymptote, which will be x equals to 1. Okay, because the x coordinate of b is 1. Then we need a point that lies on the hyperbola. Okay, since we have the equation of the parabola, which is minus x squared plus 2x plus 3 that we've just found. Remember, the plus 3 is the y cut of the parabola, which represents c. But c also lies on the hyperbola g. So c will be 0:3, and that is the point that I will substitute on g to find the value of k. Okay, so let us start with the vertical asymptote. So the vertical asymptote is x equals to a1, which I substituted there, and then I want to find k now, and I substitute the coordinates of c. K 0:3. So when I substituted them, I found that my value of k was therefore a1. Okay, and by substituting, remember I said if k is positive, that means our two-piece functions lie on the first and the third quadrants of the asymptotes. And that is true, we've seen it. Okay, now let us go to 4.5. all right, now g is that equation there, g of x equals to 1 over x minus 1 plus 4. Okay, so we have actually found the equation of g. Now let us go and answer 4.5. all right, very important. Determine the equation of the asymptotes of g. Okay, the asymptotes of g. Okay, but remember this g now is g at x plus 1, meaning the original vertical asymptote will be affected, but the y asymptote or the horizontal asymptote will remain the same. So what's going to happen? X plus 1 is the same as a 1 unit shift to the left. Okay, so it means on the previous or the original vertical asymptote, I'm going to shift it by 1 unit. Okay, so let's go and do that. So this will be, remember, the original vertical asymptote is y equals to a 4. Remember this one here, and we keep it the same. Then also the horizontal, this is the horizontal asymptote, sorry, and then the vertical asymptote was x equals to 1, but because of the shifting that has taken place that side, remember, I'm shifting the asymptote 1 unit to the left, therefore I must subtract a 1. So where there was x, if I substitute by x plus 1, then the 1 and the 1 cancels. Then I'm left with x equals to a 0. Okay, so that means my asymptotes will be x equals to 0 and y equals to a 4. Okay, very, very important. So the other thing that I want to just quickly check, I want us to come back here, all right, where we're determining the equation of f. Please take note that when we are dealing with a parabola, okay, when we are dealing with the parabola, there are three forms of ways in which you can write the equation of the parabola, okay? And then this one here is the one that we call the turning point form, okay? So there is also what we call the intercept form and what we call the standard form, okay? So this one here, which is given in the question, is what we call the standard form, okay, of the parabolic function. So obviously you will start by whatever form, but all the forms will always simplify to this particular form here, okay? And then the other thing that is very, very important that we have covered in this session are the translations, okay? You need to make sure that you get your translations very, very, very well, because you will be examined on these questions, okay? They love to give you questions on transformation and translations, and once you practice a lot of these questions, then you will be able to actually get all your marks, okay? But once you practice only a few questions, then you stand a chance of not getting total for this part here. So what I'm going to ask you to do is, please go through a lot and lots and lots of questions, okay, so that you at least, okay, get to understand everything that you are doing when it comes to translations and transformations. The more you do the problems, then the better you become in what you are doing, okay? So I'm going to ask you to please make sure that you do as many questions as possible so that you can actually get all your marks, all right? Thank you very much for watching, and also do subscribe. Don't forget to subscribe, and also share with other learners who are in the same grade as you are. And then also watch the other videos. As I have said, please, functions are very easy. I heard learners saying functions are difficult, they are not getting all the marks, and this and that. But guys, you have seen for yourselves that functions are the most easiest when it comes to math topics, okay? Functions is like your giveaway marks, okay? Once you do more questions, then you become better at your maths. The only way to know maths is to do maths. If you don't do maths, then obviously you will have a problem with maths, okay? So I'm encouraging you to do as many questions as possible, and then you will be fine, okay? So we have come to the end of this session, and I'm appealing to you to watch the lesson on past exam papers, and these papers will be kept aligned, okay? Thank you for watching, and take good care of yourselves. Please do watch other sessions, and don't forget to subscribe. Sharp.